In this lecture, we will talk about properties of logarithm functions. Let's look at the example here. We know 2 to the 5th equals 32. And how are we going to express the exponent by using base and 32 here? As logarithm, we know. Logarithm is always to find out the exponent. The exponent of what? Of base 2 to the 5th equals 32. Okay. Similarly, we know 2 cubed is 8, so 3 can be expressed as 3 equals log base 2 to the 8. Remember, logarithm is always to find out the exponent. Okay, exponent of this base 2 to the 3 equals 8, like that. Okay. Now, how about 32 times 8? 32 times 8, we know 32 is 2 to the 5th, and here is 2 cubed, that's 8. Base are the same, so then you have a 2 to the 5 plus 3. You do addition for exponents. And remember, here is multiplication. Exponent then would be addition. Now, keep going. How to express the exponent? Yeah, logarithm can be used to express the exponent. That would be what? 5 plus 3 equals log base 2 to the 32 times 8 together, parentheses. That's logarithm. Okay, look. 5 is log base 2 to the 32. So we replace by here is replace this 5 by log base 2 to the 32, because that's 5. Right here. 3, we do the same thing. Okay. Replace 3 by log base 2 to the 8. Then you know, look, left-hand side is log base 2 times log base 2 to the 32 times 8. Right-hand side is log base 2 to the 32 plus log base 2 to the 8. So basically, we changed the multiplication into addition. And here is the actual proof. This is true for general. Okay? Look at that. If a to the r is u, then r can be expressed as, because r is an exponent, like our 5 here. So then r is log base a to the u. Similarly, if a to the s is w, s, the exponent, can be expressed as log base a to the w. If you use u times w, u is a to the r, so that's a to the r. W is a to the s. Okay, bases here are the same, so you add r and s on the exponent. Now, a to the rs is u times w. Then the exponent r plus s can be expressed as log base a to the u times w. But remember, what is r? r is log base a to the u. So u again. Use log base a to the u to express r. What is s? Same thing. S is log base a to the w. Okay. Then again, right hand side is log base a to the u plus log base a to the w. Left hand side is log base a to the u times w parenthesis. Here multiplication, here addition. So this property is change the multiplication into addition, like this example. Okay. Now, we did previously is 32 times 8. How about 32 divided by 8? Again, 32 is 2 to the 5th. 8 is 2 cubed. When you do division, you subtract exponents because bases are the same as 2. Okay. Similarly here, u divided by w, u divided by w. Then u is a to the r, w is a to the s. You do subtraction on the exponents, r minus s. So the same thing. Okay. Now, 5 minus 3 is the exponent, which can be expressed by this log base 2 to the 32 over 8. There are parentheses here. Be careful. Here is the same thing. R minus s is the exponent. Can be expressed by a logarithm. That's log base a, this base a, to the u over w. Again here, parentheses. Don't forget. Okay. All right. Now, 5 is log base 2 to the 32. So we have a log base 2 to the 32 for 5. And a log base 2 to the 8 for 3. Log base 2 to the 8 for 3. Okay, this will give us right hand side is subtraction, left hand side was division. Okay, similarly here was the same. R is log base a to the u, so those two are the same. S is log base a to the w, log base a to the w. So right hand side is subtraction, left hand side was division. Okay, this is true in general. So this is property 2, this is property 1. Now let's look at the last property 3. Let's say 32 to the 4th. We know 32 again is 2 to the 5th. Okay, it's right here. And then between 4 and 5, that's multiplication. Okay, so it's 2 to the 4th times 5. Multiplication. Now, we want to use logarithm to express 4 times 5. So, 4 times 5 equals what? 4 times 5 equals this base 2 to the 32 to the 4th. So, that's basically this. Okay? Yeah. So, 4 times 5 equals this base 2 to the 32 to the 4th. Alright. Remember, what is 5? 5 is log base 2 to the 32. So this is over 5. Okay. And then we replace this 5 by log base 2 to the 32. Look. Left hand side is log base 2 to the 32 to the 4th. Right hand side, you have a 4 to the front. So it looks like this 4 goes to the front. Okay, this spot. and the rest of them are the same. Log base 2, 32. Now look at the general proof. That's parallel to this one. U to the C, 1 was over U, A to the R. Okay? So then will be A to the R to the C. Between R and C is multiplication, so C times R, R times C is the same thing. Up to this far, you want to use logarithm to express the exponent. Again, many times, logarithm is to find out the exponent. So CR, this exponent, CR, equals this log base A to the U to the C. Okay? Yeah, so CR equals log base A to the U to the C. Okay, what was over R? R is log base A to the U. So this is over R. Okay? You see? R is log base A to the U. So this was our R. And then you replace this R by log base A to the U. CR is actually C times log base A to the U. Okay? And left-hand side is still the same. That's log base A to the U to the C. So it appears you move this C to the front as a coefficient instead of the exponent. Okay? So right here, move this one to the front. It was an exponent. Now move it down to the front as a coefficient. So this will be the property 3. Okay? Those 3 properties are very popular. Times multiplication, divided by division, subtraction. And here was the exponent. Move it to the front, make it to be a multiplication. Okay, C times log base A to the U. Okay, this is the whole thing, and C times that. Here's the same thing. 4 times 5. Okay, or log base 2 to the 32. So remember these 3 properties. Now something a little bit extra.